Climate warming fuels potent toxins in Lake Erie. A recent University of Michigan study has pinpointed the organism behind one of Lake Erie's most concerning toxins, Dolichospermum, a type of cyanobacteria that can produce saxitoxin, a potent neurotoxin. This discovery comes at a time when the Great Lakes are experiencing longer, warmer summers, creating conditions that allow toxin-producing species to flourish. With temperatures expected to keep rising through 2025, the findings take on growing environmental and public health significance. Published in Environmental Science and Technology, the study used advanced DNA sequencing to examine harmful algal bloom samples. Researchers identified strains of Dolichospermum carrying SXTA, the gene that starts the process of making saxitoxin. Supplemental data from the study shows that this gene has already been detected at 19 Ohio drinking water intakes, including Toledo's, signaling its presence even when toxin levels are low. Climate change is strengthening the conditions for toxin production. The research found a clear pattern. Saxitoxin-producing strains were most common in warm water. This matches what regional climate data has shown in recent years. 2024 saw one of Western Lake Erie's longest-lasting algae seasons, according to NOAA. Great Lakes climate models project a steep rise in the number of days above 20 degrees Celsius through 2030, the temperature range where the study detected the strongest SXTA signals. Lake Erie's summer season has expanded by nearly a month, giving Dolichospermum more time to grow and dominate. As climate change accelerates, warming waters, altered stratification, and reduced ice cover are expected to reshape bloom dynamics. The concern? Species that thrive under these new conditions may increasingly include those capable of producing saxitoxin. Nutrient pollution is changing which toxins appear and where. Temperature wasn't the only factor. The study also found that saxitoxin genes were less common where ammonium levels were high. That matters because Dolichospermum has an unusual advantage. It can use nitrogen from the atmosphere, something most cyanobacteria can't do. This makes it more competitive when dissolved inorganic nitrogen is low. In western Lake Erie, farming runoff contributes large amounts of nitrogen, but often in the form of urea or nitrate, not ammonium. Several watershed assessments from 2024-2025 show rising urea levels, a trend linked to fertilizer changes. As storms, droughts, and runoff pulses shift under climate change, nutrient chemistry could tilt the ecosystem toward toxin-producing strains. Water utilities now face a more complex toxin landscape. Ohio EPA's 2024 harmful algal bloom strategy added SXTA gene monitoring for public water systems, reflecting growing national concern. Saxitoxin is especially challenging because common treatment methods used for microcystin are far less effective at removing it. This shift comes amid small but notable freshwater saxitoxin detections in other U.S. states, including Oregon, Kansas, and Utah, during the 2024 season. Together, these trends are pushing regulators and utilities toward a multi-toxin preparedness approach, rather than focusing solely on microcystin. The study helps fill a long-standing knowledge gap by confirming which organism in Lake Erie produces saxitoxin and under what conditions those genes appear. Looking ahead, warming trends will shape future HAB risk. Although the research team has 9 years of monitoring data, they emphasize that it's too early to say whether saxitoxin levels are rising overall. What is clear is that the environmental conditions linked to saxitoxin production, warmer waters, and shifting nutrient dynamics, are becoming more common. The genomic discovery gives scientists and water managers a clearer target to track as climate change continues to reshape Lake Erie. The warning is subtle but significant. The drivers of saxitoxin production are increasing, even if the toxin itself has not yet become widespread. You've been listening to Sustainability Soundbites by Environment+Energy Leader. For partnership opportunities, please reach out to our team. And don't forget to submit your entry for the 2026 awards program. Deadline is 12/31/2025.